Hey guys, welcome to day 2 of our Unit 2B notes for Algebra 2R. Today is going to be all about preparing for curve sketching without a calculator, discussing different key features of a graph, and different intervals that certain things occur on. So keep in mind that the zeros are your x-intercepts. The y-intercept is where it crosses the y-axis or when x equals 0. Minimums are your valleys, and maximums are your peaks. You can ignore the rounded to 3 decimals, that's more for tomorrow. We're also going to talk about end behavior, degree, increasing, decreasing, which is read from left to right, and positive versus negative. All right, so I'm going to give you a picture, and we're just going to talk through all these different concepts. All right, so, sorry if you're hearing some noise in the background, that's my dog shaking his collar. All right, so starting with our first graph, let's talk about the zeros. I see it either touching or crossing the x-axis at -1 and 2. Now, keep in mind that there is a kiss happening at -1, so that means there's a multiplicity of 2 there, and that comes out to 3 total roots. Our y-intercept is at 2. Our maximum appears to be at y equals 4. And our minimum is here at y equals 0. Now, typically when we talk about maxes and mins, we talk about just the y values only. If I ask for the coordinate, then you would say 1, 4 or -1, 0. Okay, D is our end behavior. So based on the graph, as I look to the left, we're going up, and as we look to the right, we're going down. So as far as sketching the end behavior, it's up and then down. If I were to ask you to describe, which I could on a quiz or a test, it would be as x approaches -infinity. So as we look to the left, our function is going up, so we'll say f of x approaches infinity. As x approaches infinity, we're going down, so as we go to the right, we're going down, so I'll write f of x approaches -infinity. Now, our degree comes from the kisses and crosses. So keep in mind that we have a kiss at x equals -1 and a cross at 2. So if kisses are 2 and crosses are 1, 2 plus 1 is 3. So this is likely a degree 3 polynomial. Now, increasing and decreasing is like a story. You read it from left to right. From left to right, I'm seeing a decrease interval, an increase interval, and then a decrease again. So, I'll kind of just do this, F and G together. We are increasing on the interval of -1 to 1. Notice how I only referred to the x values here. I don't care about 0 to 4, that's on the y's. I'm saying from -1 to 1 on my x's, I'm seeing an interval of increase. So again, these are both x values. Soft brackets because we're not technically including those values because it's neither increasing nor decreasing at -1 and 1. Now for decrease, I see 2 intervals. Our first interval is from -infinity because it's coming from way out here on the left to -1. And our next interval of decrease is from 1 to infinity. Again, x values only. Now, I've had students in the past where I've said, if you need to help looking at these intervals, try drawing a dashed line down. And that's where you're looking at your x-axis only. So 1 to infinity is where that first interval of decreases, or that second one I referenced. And likewise, between -1 and 1 is your interval of increase, and -infinity to -1. Okay. Now, lastly, what we have to talk about is positive and negative. So I'll do that over here. H and I. Now, positive is any time it's above the x-axis. So I technically see two chunks of the graph that are considered positive. Okay? The first chunk is right here. So if I were to describe that as an interval, that's from negative infinity to negative 1. Now our second place where it's positive is right next to it. So again, x values only, that looks like it's negative 1 to 2. Okay? So again, positive is above. Now you might be wondering what's happening at negative 1. Since it's on the x-axis, it's technically neither positive nor negative, which is why it's not contained in either of the intervals. It's two chunks right there. Now, negative is anything below the x-axis. So I see one chunk right here. That is where the function is below the x-axis. So that looks like it's from 2 to infinity. Okay, so to label this again, this is where it's positive. And that second one right there is where it's negative. And that's all the terminology that we would have to know for curve sketching. So we're going to do the exact same thing again with the next example. All right. So first of all, zeros. I see 1, 2, 3, 4 of them. So negative 3, negative 1, 1, and 3. My y-intercept is at y equals 9. I know that kind of looks like negative 9, but that's just part of the grid. All right, what was C? C was maxes and mins. A max, which is our high point, appears at 9. And then our minimums, we actually have 2 of them, and they're both the same. Okay? So they're both at negative 15. Okay, end behavior. This is up, up. So if we were to describe this, this is as x approaches negative infinity, f of x is approaching infinity, and same thing in the other direction. Okay, so again, as you look to the left, as you look to the right, it's up, up, no matter what. And E is possible degree. So I see 1, 2, 3, 4 crosses. Crosses are odd, so this is likely a degree 4 polynomial, because 1 plus 1 plus 1 plus 1 is 4. All right. This stuff is usually pretty good with students. Now we get into increasing, decreasing, positive, negative, and this is where students tend to struggle. Okay, so from left to right, I see decrease, increase, decrease, increase. It's like a roller coaster. Okay? And if you need to, again, you could always like do some dashed lines to help you break up that interval so that you're focusing on your number line, which is your x values. So my first interval of decrease is from negative infinity to negative 2. Because that's what this coordinate is right here. It has an x value of negative 2. Or if you look at what this coordinate actually is, it's negative 2, negative 15, and that's where that negative 2 is coming from. Now, from there, it goes to increase. So just from left to right, it looks like we're going from negative 2 to 0. Back to decreasing, so 0 to 2. Back to increasing again, so 2 to infinity. And that's increasing and decreasing. Now, positive and negative is when it's above the x-axis versus below. Okay, so above the x-axis. I see 1, 2, 3 pieces of this graph that are above, so they would be considered positive. So if I come over here, just where I have some space, it looks like my first interval where it's positive, keeping in mind that this arrow extends up, is from negative infinity to negative 3. My next interval would be from negative 1 to 1. And lastly, from 3 to infinity. Again, this arrow means going up forever. Now, negative is where it's below the x-axis. So I see two chunks where it's going to be negative. Right here and right here. So my first chunk looks like it's from negative 3 to negative 1. Again, I'm just looking along the x-axis. I do not care about how far down it goes. I just care about the x's. And then my next chunk looks like it's 1 to 3. And then we're done. That's all the pieces of this function. All right, we got one more. All right, zeros. Looks like negative 2, 1, and 3. Our y-intercept is y equals 12. Our maximum is y equals 12, and our minimum appears to be at negative 16. Our end behavior is up, up. I'm going to skip the describing because I did that exact same one in the last example. And as far as possible degree goes, I see a kiss, which would be a 2, and crosses, which are 1, so I'm thinking this is a degree 4 polynomial. All right, here's the fun, increasing versus decreasing. So I see decrease, increase, decrease, increase. And again, if you need to, I find that this actually even helps me, just drawing some dashed lines, drawing it to the x-axis to help you see those intervals. So this first interval of decrease I'm seeing is from negative infinity to negative 2. Okay, and then we move to increasing, which is right here, from negative 2 to 1. Oops, I'm sorry. Negative 2 to, what am I saying? Negative 2 to 0. I almost didn't see my green line in there. Negative 2 to 0 is when it's increasing. Or, again, look at this coordinate. This is 0, 12, so that's where that 0 is coming from. Okay, then we're decreasing from 0 to 2. Okay, so again, along the x-axis, from 0 to 2 is at that minimum on your x's. And then lastly, we're increasing from 2 to infinity. All right, positive versus negative. I see 3 chunks where it's positive, 1, 2, 3, and I see 1 chunk where it's negative. Okay, so we're positive from negative infinity to negative 2. Negative 2 to 2. Oops, I'm sorry. Negative 2 to 1, right? That's where it's crossing that x-axis. And lastly, right here from 3 to infinity. We're negative or below the x-axis in this one location between 1 and 3 on the x-axis. And then you're done. That's where it's positive versus negative. Now, this problem doesn't ask for it, but let's say I wanted to come up with a possible equation for this graph. Okay? Let's do roots versus factors. I'm seeing roots or zeros at negative 2, 1, and 3, which means the corresponding factors are x plus 2, x minus 1, and x minus 3. So putting it all together, this would be my function. Sorry for the squeaky toy in the background. Carl's been in the crate all day, so he is a little stir crazy right now. He's playing with his stuffed Gumby and his cow. Carl, shh. Okay, now the one thing you guys have to keep in mind that there is a kiss at x equals -2, so that means that for the factor x plus 2, there must be a multiplicity of 2. So we'll just throw an exponent of 2 on there. Now, since it's up, I know the leading coefficient has to be positive, so therefore I have a leading coefficient that's positive for this function. All right, so hopefully this video helps determine the difference between positive versus negative and increasing, decreasing. These are all the concepts that we'll emphasize again tomorrow, but with the graphing calculator. Have a great day.